Hello, I'm Cy, the IT Guy Williams, the owner of TeamLogic IT of Orlando. In the previous video, I provided an overview of blockchain technology. In this video, I'm going to discuss how blockchains work, the role of miners, and blockchain immutability. A blockchain is a peer-to-peer network that consists of wallets and nodes. A wallet can be a mobile or web-based application. It has an address that can be the source or destination of a transaction. Wallets are used to create transactions, cryptographically sign the transactions, and communicate the transaction to the nearest node. Full nodes, sometimes called miners, receive all transactions either from a wallet or from a peer. Each node will validate all transactions and bundle transactions into blocks. Each new block is connected to the previous block by placing the hash value of the previous block into the new block. The logging of the previous block hash value is what creates the chain. A hash is a fixed-length cryptographic representation of the data. When a node finds a specific hash value for the block it is creating, it will add that block to its local copy of the blockchain. The node will notify its peers that it has successfully created a new block. All peers will validate the new block before accepting it or adding it to its local copy of the blockchain. So let's talk about what a hash is for a second. A hash is an algorithm that takes data input of any length and derives a unique fixed-length output. A hash can be thought of as a fingerprint of the data. The creation of the hash is a one-way process, meaning you can convert data to a hash, but you cannot take the hash value and convert it back to the data. The National Institute of Science and Technology has published secure hash algorithms referred to as SHA algorithms. Bitcoin uses secure hash algorithm SHA-256, and Ethereum uses secure hash algorithm SHA-3. The one-way hash translation provides a mechanism to validate data without revealing it. So there's one key characteristic to a hash that I want to mention here, and that is simply a small change in the data that you're hashing results in a huge change in the hash value. So in this particular example, your managed IT service provider, the value below that is the SHA-256 hash of that phrase. If we make one change to the phrase by taking the uppercase y and converting it to a lowercase y, we have a huge change to the hash value. Public key encryption sometimes is referred to as asymmetric cryptography. Public key encryption uses two mathematically related keys, a public key known to everyone and a private key known only to the recipient of a message. Your public key is used to encrypt a message and can be shared. Your private key is used to decrypt messages. It can be used to sign transactions and should remain private. All transactions are digitally signed using private keys. So as I mentioned previously, all blocks are linked to the previous block via the previous block hash value. Any change to a block will change the block's hash value and invalidate succeeding blocks. Invalid blocks won't be accepted by other nodes in the blockchain network. The other nodes will not add this change to their local copy of the blockchain. That's how immutability is accomplished in the blockchain environment. If you don't know, now you know.